So my name is Arash, everyone. I'm the person that will be hosting this class. Wanted to welcome you guys in. Hope everybody's staying safe. I know we're going through a difficult time, and this is how we're going to be conducting our sessions. So wanted to share with you guys a few things that 3D printing has done in my life as a designer and robotics. By hobby, I really enjoy building robots and just making electronic stuff. And now 3D printing is very, there's a lot of misconceptions about it. A lot of people think it's very expensive. That has changed. It used to be very expensive. Now we have, you can buy a very nice 3D printer for around $200. Yes, it's not going to be top of the line. There's always going to be something that's better than that, but you can get going with around that much. So that's one of the common misconceptions about it. Another misconception is that the material for it is expensive. Again, that's not true. The material is pretty decently priced. You can get a roll of spool, and I'll show all of that later to you guys. You can get a roll of spool for roughly $24, and that lasts you, it depends on how much printing, of course, you do, but you can, that should last you around 3-4 months of making, if you're making things that are maybe this big. So, so again, that's another misconception about it. Now, 3D printing is, it's a lot of people, I've had people say, oh, it's for making toys. Yes, it is. You can make toys. I made this. This is it's a very common, popular model. As you can see, it's a lizard or a gecko. This was all printed in one part. So what 3D printing, the style I have is the FDM. So what it does is it goes layer by layer. So it melts the layers on top of each other. Now, I don't know. Yeah, now you guys should be able to see the layers on this. So it just goes up and it ends up intertwining parts to each other so where they can be flexible like this. So these are the toys you can make. I guess it's a glorified toy maker if you look at it that way. So what else you can do is you can make robotic parts. So this is a robotic hand that I designed on Fusion 360. And as you can see, it has articulating parts. So when you move one servo, you can see how it all moves together. So pretty much you can be prototyping, building robots, or making household items. So for household items, just simple stuff like shelving and everything like that. But I went the avenue of more of robotics and all of that. So again, it's not quite a toy maker once you look at it a different way. So this is a robotic quad walker. As you can see, like you can just get all these aftermarket parts. If some of you are not familiar, this is called an Arduino. So it's a microcontroller. You can pretty much program it to do whatever you want it to do. It has a basic input-output, sensors and all of that. So I put, you buy these servos, you can measure everything the way you want, and you can design what you want. Now, these are for people that are more familiar with 3D designing. Now, if you're not too familiar with 3D designing, there's also other sources available online. One of the most popular one is Thingiverse. I'm going to go ahead and share my screen with you guys. Where is it? There it is. So let's go ahead and share it. So yeah, as you can see, this website is called Thingiverse. You can find all of these models. They're all for free. Now, some of you may want to, some people like to tip these people, and they end up just collecting donations. But other than that, you can get these models for free. I mean, literally, you just go, let's say, oh, I wanted to 3D print this. And you just go here and you say either download all or download. Doesn't even require registration. So once you download, so let's say I just downloaded this. See, that easy. So then what you do is you put it on your 3D printer, and next thing you know, you have a baby Yoda appearing out of nowhere. So these are the cool stuff you can make with them. Again, these are what you can use to get started. It's pretty simple. There's a lot of conceptual things you need to learn about 3D printing. So for example, you see this ear? So as I said, it goes from bottom to top, layer by layer by layer. I want to get close so you can see the layers. You see those layers? So these are all layers of molten plastic that's going on. Well, what happens here is, I mean, it just based on the laws of physics, this ear would not, like, because it's molten plastic, it's going to start sagging. So what 3D printers use is these things called supports. So while it's printing from bottom, it's going to do these layers of very thin plastic that will go under the ear. So once it reaches there, it lays the layer on top of those, what's called a support. Another thing with 3D printing is that the bottoms of them have a hard time sometimes, actually a lot of times, they have a hard time sticking to what's called the print bed. That's the surface at the bottom of the printer. So they have a hard time sticking because, here's why. So when we have a 3D printer lay hot molten plastic, okay, when it lays it down on, let's say, a cold bed, what happens is the difference in temperature makes the plastic start warping. So once they warp, the bottom will not be as smooth and nice as this. So when it's not as smooth as nice, it ends up sometimes detaching. So when it's in the middle of the print, so the print head is going up and down or is going up, sometimes it'll knock it over, and next thing you know, you have a blob of plastic waiting for you. So those are the things that a lot of new 3D printing people will experience, including myself. I experienced it, but it is a very cool rabbit hole to jump in. So it takes you deep in, because you're going to start doing all these printings and you're like, well, why does it do that? Why does it do this? And you start researching it. You can go on Google and type it in, and you learn so much. But once you learn it, you become a pro at it. I mean, you can make so many cool things. And sometimes, you know, it just does it from the beginning. Now, that's what the difference between cheaper and expensive printers are. Some printers don't have heated beds. So a heated bed, as I said, is the surface, but when it's heated, it actually keeps the molten plastic level and it keeps it stuck to the bottom, so it won't detach. So that's the cool thing. So the more, let's say, you pay, the more you get these cool features. Like, well, another thing is bed leveling. The most important thing for a 3D printer is to have a level bed. Meaning, so this is a print surface, this is a print head. If it's far away, it's just going to start pouring plastic midair. But once you level it, you change the knob or whatever to keep it close enough to be able to lay it down. Now, I'm having somebody in the chat say something. Sorry about that, guys. I'm going to stop my screen share and see what temperature should the bed be for PLA. So the temperature, so that's a good question. So somebody's asking me, what temperature should the beds be for the PLA? The bed usually has to be around 50 to 60 degrees. Now, there are different qualifications for different even PLA plastic. So that's, PLA is the name of one type of 3D printing plastic. And for just PLA, regular PLA, it has to be 50 to 60 degrees. Now, some of them have it on the spool. it'll say what the bed temperature should be and what the nozzle temperature should be. Nozzle temperature can be around 200 degrees. Now, again, that's different on certain ones. Like, for example, there's different types of PLA like wood PLA. So it has wood grains into it, or that's what they say. It's a mixture of wood powder and plastic, the PLA plastic. And based on different stuff that's in it, you have to change the temperature. Now, a lot of manufacturers provide that for you. Back to the 3D printing parts. So when heated bed is very important. So my first printers that I have, where you can see that little orange one, I bought that years ago, and back then heated bed was, I guess, expensive, new technology, whatever. So it didn't have it. So I had a lot of warping issues. Again, warping is when the plastic starts bending because it doesn't have a heat chamber or whatever. So some 3D printers are enclosed in a chamber to keep the heat in. So these are things to look at if you are looking to buy 3D printers. Anyways, we have, and then also with 3D printers, when you calibrate them right, you can 3D print them from bottom to top in one piece. So this is one of the examples of the one piece ones. So as you can see, when you turn it, they all turn. And it's actually pretty fluid. So you can always do test prints like this. Once, let's say you achieve this, that means your 3D printer is calibrated right, because the lines in between, they ended up adhering good, and they're far apart from each other enough for it to freely spin like this. So these are like, if you can 3D print this, your 3D printer is a good 3D printer when it spins freely. I'm personally a big fan of a 3D printer called Creality. Now, there are MakerBots and everything. MakerBots, in my opinion, are good 3D printers. They're very easy to go. Now, if you like tinkering, I'm going to show you the Creality that I have. So now it's actually printing. So it's going layer by layer, as you can see, and it's laying down the hot molten plastic and just going over. Now, 3D printing also takes a very long time. So this is one of the models that I'm printing. Now, just due to our circumstances nowadays, some people might have seen this. This is pretty much a part of a face shield for people to wear to block out viruses or whatnot. So this is a finished piece. Now, this takes around an hour and a half to print. Small part, but that's one thing to keep in mind. 3D printing is not a quick job. It's not like printing with just a regular paper printer. It takes a very long time. This Baby Yoda that I have took 4 hours to print. One thing also to keep in mind is 3D printers the speed of the 3D print depends on how thin the layers are. So logically, the thinner the layers are, the more layers you have, the longer it takes to print. However, that's how you get such detail. As you can see, the details on this is very nice. I mean, this is almost ready to print. Some people end up sanding these, making them more smooth and printing them. Oh, I have another question. What inexpensive 3D printer would you recommend? Well, the one I bought is called a Creality. So pretty much like reality, but with a C at the beginning. Creality Ender, the one I showed you is an Ender 5. I have a Creality CR10. That's the bigger one I have. It's the little orange towering one. Let me show you. So this is the bigger model. It prints pretty high. I mean, if you look at it, It can go from the bottom to all the way to the top. So it has a very big print volume. If you want to 3D print a lot bigger parts, like let's say if you're making an Iron Man suit, which believe it or not, people have made it. So go on that website I told you, Thingiverse, and you can see, I mean, they have all the parts listed. And people are building them and wearing them. It's really cool. So you can make bigger stuff with this. This is a $450 printer. This is a $300 printer. So this is a slightly different style of printer. This is, the bed goes down. With this one, the bed stays down, but the head goes up. So it's just different styles of 3D printers. Now we have also resin 3D printers. They're a lot more expensive. However, they achieve really detailed prints. So if you're making a lot of articulate small parts, you want to get a resin 3D printer. What the resin does, what the resin ones do is, so you have this liquid resin at the bottom, and the head ends up going right against that liquid. And then you have these lights. The light ends up solidifying the liquid. So when it shines the light, it does it in pulses. When it shines the light, it ends up solidifying the layers. So this would be, so the baby Yoda would be upside down, the bed would be raising, and pretty much the Yoda would be being built like this. So it will pull it out slowly. Now that takes, again, same amount of time, maybe a little bit faster, but you get a lot better detail. And again, if you're a beginner, detail might not matter too much to you. You just want to get started. Yes, Ender 3 Pro. I have someone saying that they have the Ender 3. So I have the Ender 5, Ender 3. They're actually very comparable models. They're just slightly different. Ender 5 has different features on it. So does the Ender 3 Pro. So, but they're very popular. And I'm sure Simon would say that, I mean, unless you have questions, but they are fun to build. They're kits. Again, that's why they're cheaper, because they're kits. Now, don't get me wrong. The Ender 5 took me 30 minutes to build, and I went step by step. I never skipped steps. Even though I've built 3D printers before, I still read every line of every, instruction. So let's say if you're not too much of a pro, it might take you an hour to build. So the kits now, again, are different than the kits back in the day. For example, the Ender 3, I believe, takes longer to build. But again, you get awesome results from them. So those are the 3D printers I recommend. Just based on personal. So now I wanted to show you some of the other stuff I've made. So I grabbed a mini Arduino and a chip, and I combined them together to make this microcontroller practically. So if you guys are familiar with Vex Robotics, this is practically the same concept. You connect the servos and you connect it to whatever. So, and again, these are all my designs here. So this is a robotic arm, as you can see, little gripper, and moves around. So you can pretty much program this chip to articulate this robotic arm. So you can make a lot of really cool stuff. This is a very, I mean, if you definitely are into STEM, get into 3D printing. You will not regret it. It is, convince your parents if you need their permission, convince them, have them watch this while I'm talking. We're recording this session. So, make sure, share it with them and let them know how much cool stuff you can do. Yeah, so these are, so again, this is this. Oh, and another one of my projects that I've been working on. Now, this is someone else's design that they made available online. By just looking at it, you might be able to guess this is a robot vacuum. So back in the day, I really wanted a robot vacuum, and I had a 3D printer, and I like electrical tinkering. So I went ahead and found a design that somebody else made, And they made it free, available online. And sometimes with the free stuff, when they make them available online, you got to be really cautious because they don't put full directions on. So what happens is you invest all this plastic. This took 14 hours to 3D print. You put all this plastic into it, and then you realize that 10 steps are missing. So you can't finish the project because you're like, wait, this guy put all this awesome stuff, but he missed a few steps, and I don't know, and they're not answering the questions. But, well, this is not the case, but I've had that happen. So always be careful with these very, I guess, because this was a bigger project. So, but this one runs. So, and I'll go ahead and show it to you guys. So I put this little old switch. I do need to print the top. I ran out of plastic at the time, but anyway, so you just turn it on. So it's pretty cool. So it's on. It takes a few seconds to start activating. Again, using the Arduino chip in it. So check this out. So now the wheels are turning. Now look at this. When I put my hand in front of the sensor, well, I'll wait for it to start. So that's blowing out the air. It's sucking in the air from here. It gets pretty loud. So it sucks in the air through here. You can, and it has this like, you can build the little filter part yourself, put paper towels or whatnot for the filter, or you can just grab a piece of filter and cut it, put it in here. And these sensors end up activating. There's a bump sensor up front. I don't know if you can hear it. You hear the ticking? So that's a bump sensor. So it bumps into stuff, it'll back up and turn. And it has these two sensors here that these are pretty much proximity sensors. It goes up to here and then it'll back up without bumping into it. So it has, and that's it. A lot of vacuums, they have a lot more sensors, the ones you can buy, like the Roombas and everything. But yeah, this is just a homemade vacuum, robot vacuum, and it works. I've used it before, but I do want to finish it because it's a really cool project. So yeah, there's many projects you can do. I mean, I have countless. I have a little daughter, so I make her these stuff, and she loves them. She starts playing with them. And also, some people may be under the impression that these are they're fragile or whatnot. They're actually not. Depends on how you print them. So you can change different settings on what's called the slicer. That's the software that uses your 3D design. So let's say I go download this online. I suddenly think, I say, hey, I really want this to be solid. I want it to not break. I want it to be very heavy. Okay, so if you think about all those, that means when you say heavy and strong, that means more plastic. The more plastic, the stronger there is. The stronger they get. So you put more plastic onto it using the slicer. So you say, I want more wall layers. So what wall layers means, if this was only one layer of plastic, it would be pretty breakable, pretty fragile, kind of like an eggshell. But if you have 5 wall layers, imagine just 5 rows of plastic as it's printing. It takes longer, but it makes it super strong. And you can hear it. When I tap it, it's pretty solid, right? So you can change that using what's called a slicer. So you download this. Once you download imagine if this is a 3D model, you download it. You put it in what's called a slicer. You just, click and say, put new file or whatever. Once you put it in there, it actually will generate the image like this, and you can change the settings on it. Pretty simple. I would recommend Googling it. Like, for example, you say, well, what's a raft? Well, the raft is another layer that they print at the bottom to make it stick to the bed better. So if your 3D printer is already sticking well, then no problem. But if it's not, then you put a raft and then it sticks better. I have another, can we get the file for the gecko? Yeah, I'll actually, let me share my screen again. Where is that? Okay. So So I'm sharing my screen. I hope you guys can see it. So just go to thingiverse.com and then just type in, I think lizard is what brings it up. So you just type in lizard. Look at that, first result. So then you just click on it. Again, if you guys want, this website is freaking awesome. It is a great website. You can find so many cool models on it. So yeah, you click on the get-go and then you say Think Files. They have different versions, some designers, and then they have it in their notes why it's changed. And you just click download. So you know what, let's actually download it, and I'm gonna show you how the slicer works. So right now it's downloading. Again, I want to show you how easy it is to get it from the computer to a 3D printer. This is just to take away misconceptions about 3D printing. So you just click on it. You wait for, so Ultimaker Cura, this is a slicer that is free. It's very popular. You have roughly about 80% of 3D printers use this. It's free, available for anyone to download. Again, just Google this name, just say Cura, and it will come up as one of your first results. Now, once it's loading, give it a second or two. Any day now. They'll start, don't worry. But yeah, so while it's doing that, so okay, yeah, there we go. Being slow. You can just pretty much 3D print using that. And then let's say I designed this. It took me, and 3D designing is a whole different story. It takes a lot of playing around with it to figure it out. Again, one popular one that I use is called Fusion 360. It is a very, very good 3D designing software. Oh, wow, this is taking forever. Yeah, so you design these. It took me roughly 30 hours to design all of this because you have a lot of trial and error. Like you have to resize things to make sure it perfectly fits. Certain things like these joints take a lot longer to print because, as you can see, I have, oh, there you go. So you have to really tinker these to make sure it fits perfectly. And then, I mean, even the gap between this, I mean, I had issues with that. So it takes a lot of tinkering. You will end up, let's say, I guess, wasting a lot of plastic. Now, one thing to know is that these parts are PLA plastic, not, there's other types such as ABS, that's another popular one, or PTEG. Those are, again, other popular ones, but PLA plastic is actually biodegradable. So if you are wasting a lot of it, which you will end up doing if you're a prototyping person, you don't really need to worry about the environmental impact it has. I think now, I may be wrong about this, but it takes maybe a few years for it to dissolve if it is in nature. So it is one of the more environmentally friendly products. So PLA plastic. So yeah, but once you make these, it's really cool stuff. So I'm actually in the process of designing an external robotic arm, so it's the same as this, but big, something I could wear. So it would replicate my movement with the robot. Now, I'm only in the designing phase, so I don't have anything to show off of that. So anyways, so here's the model. So as you guys saw, I downloaded it, I clicked on it, it opened it in Cura. And then here are the settings that you can, oh wait, I don't know if you guys can see this. So let me stop share. I'm going to share my Cura screen because I think I wasn't sharing that. So sorry about that. There we go. So this is the Cura model. It downloaded it. opened it up here, and this is where you get the settings here. So so quality, that's what I was telling you guys about, the wall layer. You can change the quality here. So when you click here, so super quality, again, if you don't really care about the technicalities, these you will catch on later on as you're working with it. So you'll realize, oh, 0.12 millimeter is really good quality. You remember that just because you keep using it. So these are different qualities. So I have it set to low quality. And when I say slice, you'll see how the difference is to printing. So this is probably, just off my head, I would say it would probably take 6 to 8 hours to print just because the parts are so small. It might actually take longer, but we'll see. So once it's slicing, you know, and what slicing means is it's generating this thing called, oh, 2 hours. Okay, well, I overshot that. But yeah, so when you change the quality to a lot finer quality, so let's say super quality, and I've made a lot of changes, so I'm going to keep that. You'll see how long it takes. Somebody else is asking a question. That's weird. When it's screen sharing, it won't let me see the chat. Yeah, it's not letting me see it. Let me stop share again. Ah, it just popped up and then disappeared. So does it need supports? No, it does not need supports. You can just disable supports on it because I've actually done, this was done without support. Now with a support, there are the breakaway parts. So remember the example I gave you with the ear? So it's gonna be doing a plastic up to the bottom of the ear and then it snaps off. Sometimes it leaves these little residues on there, so you have to sand it. So imagine if you had to put supports on every joint on this, it would be really hard to clean all of it up. So I would not recommend supports. Again, these are all trial and error. So you do it, you grab a 3D printer, let's say you make this and you're like, oh, the supports makes it take longer, I want it to be quick. You do it and then the ears end up sagging down and it just doesn't look good. Then you realize, okay, maybe I should have put supports on. So those are a lot of questions that you will ask. Does it need support? Does it need 4 layers or 3 layers? Does it need, I mean, something like this, the Baby Yoda, this, I can run over it with my car and it won't break. It won't, because of how strong of a plastic this is. So again, but you have to add layers. You have to make the parts dense. There are parts right now, we actually have it at our, what's the name? We have it at our Fab Lab. We have a 3D printer called the Mark Forged 3D printer. And that part, this is the cool thing. It infuses different types of plastic or not plastic, but different types of material, such as carbon fiber, meaning it would make it super strong. And literally, the guy that trained me with the Mark Forged at the Fab Lab, when he trained me, he showed me a part that they were making for the Mazda concept car that they were building. So Mazda contacted them and said, hey, I want you to 3D design, let's say a shifter or whatever part, design it for our prototype. And again, these prototypes are so strong that they can literally be used on the concept car. Now, once everything is good, let's say once I build this and everything is good, you send the files for manufacturing. When they send it for manufacturing, now this is for people who want to maybe one day build a business, right? Once you send the 3D designs to them, they end up manufacturing it in large volumes. So again, these are all very everyday use. You can use it for making, you know, day-to-day household stuff, make toys out of them. A lot of people use it for cosplay. So, you know, you have an Iron Man suit on, you have a Batman suit on, a lot of Stormtrooper stuff, if anybody's a Star Wars fan. You can make Kylo Ren's mask. I mean, if you Google that stuff, I mean, if you go on Thingiverse and type in Kylo Ren, you'll find the mask for free, the 3D design for free, where you can download and 3D print. So there's a lot of support out there. And I mean, that's how I learned about it. I didn't go to school for it, but I learned it just by researching online. And you find a lot of resources, a lot of helpful people in the community. And again, our Fab Lab now, there's going to be like, I think 20 people just like me waiting there to help you guys. We have one of our guys that made a mock-up jet engine that actually spins and everything. I mean, everything construction-wise is part of a jet. We have people that their husbands and wives work in these industries where they actually 3D design drones that are being used by the military. I'm not talking about toy drones. I'm talking about actual military $1 million, $1 billion drones that they 3D design, 3D print those parts, and they end up, I mean, they have a job for it. So there's a lot of demand in this field. In the artistic way, there's fashion shows that they 3D print shoes, they 3D print clothes parts. I mean, it is limitless on how much you can do with a 3D printer. So it's a very fascinating world. If you like making stuff, this is the road to take. And again, we have at our facility, we have friendly staff, and online we have there's friendly people online that are so helpful. You can research so many YouTube videos on. There's even YouTube videos on how to build the Creality. I mean, there's tons of them. So it's a really cool world I really love. I mean, I used to build robots since I was a kid, but with cardboard. And then when I grew up a little bit more, my parents let me get a saw. I was a lot older, like maybe 16, 17. So I started making them out of wood. So I had like these wooden robots walking around. It was really cool, really fun. And then once 3D printing came, blew my mind. I said, oh my goodness, I can make anything I want now. So I learned how to 3D design. Now, here's one last thing. I'm pretty much done with our session. But another cool website to check out is called Tinkercad, Tinker, and then CAD. It's a CAD software. It's an online free CAD software. That's actually what I got started on first. I wanted to learn as quickly as I can how to 3D design. Tinkercad was the best start for me. It is, when you look at it, if you're an adult, it might look like it's very colorful. So some adults might be like, I'm not touching that. I want to learn Fusion 360. You can, but Tinkercad will get you started on the concept. So you learn the concept of 3D designing on Tinkercad. Again, let me know if, shoot me an email. You guys have my email. So shoot me an email if you guys forgot some of the websites. I'll be more than happy to share them with you. But yeah, so it's Tinkercad was a great start for me. I started my first 3D designs on that. Then I wanted to do more, so I said, is there any better software? And then I came along Fusion 360. There's also, you know, all sorts of, there's Blender and all of that. Those are the free ones. They're very fun. You learn as you go. It took me maybe 2 days, of maybe 2 hours each day of playing around with Tinkercad, and I had something 3D printing right after that. So I will warn you now, because of the situation we're in globally, 3D printers are in high demand. So you may have a hard time buying it. It might have a month wait time till you get it. But again, go on Amazon, go on different websites. You can find different priced ones. Amazon is a good resource because you see people's reviews. So I like doing my search on 3D printers there. So yeah, that concludes the presentation. So anybody have any questions? It could be as specific as it can be, or any general questions. You can either write it in chat or just unmute yourself and ask. I don't know how long I'm supposed to wait for this. I can wait maybe 10 more seconds. Think about your questions. Could you please send me the web links? Yes, I can. Yeah, after this is over, let me see. All right, nothing. Okay. All right, guys. Well, this was fun. I hope you learned a lot. I really do. This is one of those exciting things. 3D printing is like I could talk about all day. Absolutely, no problem. Glad you guys enjoyed. Hope you learned a lot. Hope you got a lot of resources just to get a concept of it. Again, feel free to send me an email if you have any more questions later on down the road. We are available. Again, from the Fab Lab, we're all available. We all are people like me. It's like we all love playing with just different technologies. So contact us anytime and we'll be more than happy to help you guys out. All right? You guys have a great day. Stay safe.